Hello, in today's video we're going to be talking about precipitation reactions. Now we have very specific rules for what identifies something as either soluble or insoluble. Something that is soluble means that when it's placed in a solution it falls apart. It's an ionic bond that just falls apart. So you'll have those two different ions, a cation and an anion, floating around in solution. If we're talking about insoluble materials, that means that when you put this compound into water or a solution, it remains in its compound form. So it does not separate when it's in the water. So these are the 5 rules that we will be using for this class. Your textbook has about 8 rules, but we're only going to be using these 5. So I will give you a list of these. I'll give you these on the notes so you don't have to worry about using your textbook. I will also always give you these solubility tables on the exam, okay? So here, let's go through these. The first rule is all salts of nitrates are soluble. Anything that has a nitrate in this class is going to be considered soluble. So if I were to say NaNO3, that's nitrate, the NO3 minus is nitrate, this is going to fall apart, and it's going to fall apart when we throw this into water into Na plus, which is aqueous then, and NO3 minus, which is also aqueous. So this is what it means to be soluble. When I take the compound and I put it into water, if it's soluble, it becomes its ionic form. Great, so that's the first one. All salts of sodium, potassium, ammonium are soluble. Anything that contains the sodium, the potassium, or the ammonium will just fall apart in solution. So that's the same thing as saying potassium SO4, potassium sulfate. If I drop that into water, this would fall apart into 2 potassiums and 1 sulfate. The reason why it's falling apart is because the rule specifically states that it's going to fall apart when it's in solution. Great. Third one, all salts of chlorine, bromine, iodide are soluble except for silver 1, lead 2, and mercury 1. This is the first time that we see this except. So what that means is if I have a lead 2 chloride, PbCl2, that's lead 2 chloride, and I put this into water, nothing is going to happen. I'm still going to get PbCl2 in its solid form. So that is what it means by except. If you have the chlorine, the bromine, or the iodine bonded to any of these 3, they will remain as their solid form in solution. So this is the except. Now if I were to do this with anything else, let's say I had the, let's say strontium, SrCl2, that's strontium chloride. If I put this into water, all salts of chlorine, bromine, and iodide are soluble except for these. Well, strontium is not part of this, which means it's going to fall apart. So this will turn into strontium 2 plus aqueous plus 2 Cl minuses, which are aqueous. So that's how we should read this table. Okay. The fourth rule, all salts of sulfate are soluble except for strontium 2, lead 2, and mercury 1. And then if we go through the list and nothing is found on the lists, whatever compound you're dealing with is not found on the list, it is considered insoluble. So this rule number 5 will come up regularly. So I'm going to get my little cheat sheet and we can go through an example. Let's say we have calcium chloride, which we know is aqueous. The reason why we know it's aqueous is because it's a chloride and calcium is not part of those 3, plus sodium fluoride, NaF, aqueous. We know sodium fluoride is aqueous because of rule number 2. Now we want to predict what products we can make. Well, this is going to fall apart according to the double displacement rule. The cation of this one is going to try and bond with the anion of this one. So we're going to try and produce calcium fluoride. And then we're also going to try and produce sodium chloride. The cation of this one is going to bond with the anion of this one, or try to, NaCl. So now we have to go through and we have to check what their states of matter are, and then we can balance the equation. So when doing this, you don't move over the Cl2, you only move over enough of the chlorines in order to neutralize this compound. So we'll balance it at the end. Here, let's check the calcium fluoride. This doesn't have calcium, rule number 1, or fluorine. Rule number 2 doesn't have either one. Rule number 3 doesn't have either one. Rule number 4 doesn't have either one. So by rule number 5, calcium fluoride has to be a solid. Now we have to check sodium chloride. Rule number 2 says all salts of sodium are soluble, AQ. So now we can go through and we can balance this. We know that there were 2 Cls on this side, 1 Cl on this side. We're going to put a 2 here. We're going to put a 2 here. So this is now a balanced chemical equation. We were able to predict what the products were going to be based on a double displacement reaction, and then we were able to predict what the states of matter were based on the solubility table. So we're going to be dealing with the solubility table quite a lot for the rest of the semester. So you're going to become very familiarized. You're going to be very familiar with this table by the end of the semester. And with that, that's all I want to say, and have a good night. I'll see you all in class tomorrow.